Welcome, everybody, to our 110th webinar since we started these webinars back in March of 2020. This is the 36th of 2021, and we have a treat today. We do a lot of these webinars are technical in nature, where we talk about what button to push and how to understand the squiggly lines or the channels reports and all the different things that racers need from their data. But today we're going to take a little bit of a different path and chat about chat with Chris Willis, who wrote a book, a fantastic book that I bought literally the week that it came out and have enjoyed it to the point of chasing him down and trying to get him to come join us and stalking maybe, who knows, but
Wasn't that hard? Wasn't that?
not that hard to find you, right? But
Had me come on for sure.
exactly, and have got to chat with him for the last week or so as we've gotten ready to go in it, and it has done nothing but add to the coolness of the book and some of the stuff that some of the stories that he has to tell. And it's one of those things that those of us who are in motorsports and or any competitive thing is you, some of the stuff you do, it's hard at the time, but boy, when you look back, there is just such a such a joy in looking back at something you've done with a whole bunch of other folks and working hard and finding success. And this book he put together is that story of the Electramotive Nissan GTP car, where they built this and put this program together. And it's so well done. Thank you, Chris, for coming and joining us. We're going to chat about some of the different stories, and I just appreciate you coming and chatting with us.
Yeah, well, Roger, I really appreciate you asking me to join, and I appreciate everybody signing in to listen.
Absolutely, we'll have a good time. I've got a copy of the book here. I've got some notes on the side. We'll chat about some different things. It is a big book. I have to lean back a little bit. It's a hardback book. It's a coffee table style book, and well worth taking a look at. We'll give you some options of ways to buy it if you are interested when we get to the end of this. But it's really, really interesting. Let's introduce Chris a little bit more. I don't want to spend. Obviously, his career has been very full. He's a motorsports lifer, and as a mechanical engineer, yeah, applying that trade into the motorsports world. And certainly the top couple lines on this resume is what we're going to chat about. Focus on the electromotive side with the IMSA GTP cars, and even a little bit earlier than that when he came to work there. But what I thought was interesting is, of course, he was a big part of that program, and then somewhere in all of this, he took time to write a book about it. But he has been a working engineer, working in the field in cars and series that you would recognize here in the States, as far as in road racing and off-road racing. So I wanted to leave that up there, all the way down to a Trans Am car that has won in the series and is still winning. He designed and helped engineer the real-time Honda Civic that ran up and down
TLX, it was
Pikes
a
Peak.
Honda TLX.
TLX, I'm sorry, that ran up and down Pikes Peak, and tons of interesting stuff, including a stint at the Indy 500 as a race engineer for Jacques Lazier. So that's some pretty interesting stuff there. We're going to focus on the Nissan, but I just wanted everybody to know that he's been out there working and doing some pretty cool stuff. I seen a note over here also, some stuff from the Saline Mustang, and somebody in the chat box was talking about that. Yeah, he was a part of that as well. So
That was a really cool project to work on for sure. Yeah.
Yep. And then another one that we chatted about that we're not going to talk too much about today, but also did some design work on engine components for Chrysler Mopar V8 LMP program that 2001 24 Hours of Le Mans, fourth overall. So not just chassis stuff. We're going to talk about some engine stuff, transmission stuff today, brakes, some of the stuff that he worked on as a younger man back in that time frame, right? So
yeah, everything I learned at Electramotive and Nissan, I've used throughout my career, and I still use what those guys taught me today. So it was a great experience for me.
I think that we're all that way too, right? It's we learn something, and in this case, you learn from true great professionals, and we are just a body of everything that we've ever done and learned, right? As we continue to move forward. So interesting stuff.
Especially the way Electramotive approached racing from an engineering point of view. Not, if we broke apart, it wasn't just make a new one bigger. It was analyze the problem and design a new piece, sometimes lighter than what was there, but stronger because you knew the mode of the brake. So it was really a eye opener that you could use engineering in racing, in all forms of racing. So.
And you talk a lot about that in the book, where it's certainly it wasn't a new concept, but it wasn't used heavily all the time, right? This was a large effort, obviously, but the some of the stuff that we did, one of the things we're going to talk about is the engine block, and some of your work on that, and some of the CAD drawings. And when you first started with hand drawings and moved into CAD, they really did take an engineer's approach to it. So pretty interesting. I wanted to show a few slides of what the book looks like. These are some screen captures that Amazon has that just grabbed, just give you a feel of what the book looks like, and then we're going to chat about some of the details. There's the EECP, the engine electronic engine control processor. We're going to talk a little bit about the data logger as well.
So they called it a processor because it didn't have any data collection; it was only processing. So.
There you go. A little bit of what the chassis looked like without all the body work. There is virtually pictures on every page of nice color, clear pictures, and as you walk through, we can see the process that the team went through to build these things. It's just an amazing thing. And then the last couple pages here that I just wanted to show before we jump into some deep discussions are he also put together from many different sources, it sounds like, to race results of those years that he was there. Hey, the one on the left here, race 4 of the series, round 4, race 2, 500 kilometers, who the drivers were, and then a bit of text of what happened during the event. Pretty interesting. How did you get some of all of this information for each of these races?
Well, when I started working there, I got On Track magazine, and I used to keep all the issues of On Track, and eventually I made a whole scrapbook of all the articles from the Nissan races, and so I used that. I went back through that to write the storylines, and then also went on YouTube to remember watching some of the races and what actually happened in the races. So yeah, it was fun getting back into that and watching all that happen again, and so that's kind of how the storylines.
Speaking of which, let's kind of set up your role there a little bit. We'll get to the next couple of pages, but you didn't necessarily go to all of the, or even many of the races. You were the engineer doing the heavy, that heavy work back in the office. What was your role? You came in, I think, in '86. Started on the engineering side. What was your role in the building of the car, and then of course the running and testing of the car?
Yeah, I wasn't part of the traveling team. I did go to like Road Atlanta, and I was actually at this race you're showing on the screen. I was a signaling board guy, so it was kind of fun. But my dad got me into racing a long time ago, and when I was 4 years old, I went to my first race. But my dad and a guy named Wes Moss, who's the engineering manager at Electramotive at the time, they used to race together, and so. He told me when I graduated from college to let him know, and if he's got a job, he'd hire me. And sure enough, he did. So 2 weeks after I graduated, I'm on a red-eye flight to California, and I became just the design engineer in the office. So Wes was the technical engineering guy that, he super smart guy. He actually worked on the Ford GT programs back for Holman Moody back in the day.
Interesting.
So he had tons of experience and knew how to properly engineer a race car. And so he taught me a ton, but I was basically there doing drawings, and so I wasn't part of the crew on the team. They only took the crew to the track, and me and a guy named Bruce Parrish, who was the fabrication manager, we both stayed at the shop while everybody went, and we continued working, doing whatever was the next thing on the list. So yeah, I was basically there doing hand drawings. It was all on big drawing boards, and everything was drawn full size by hand. There were no CAD systems that we had back then. And so yeah, it was just basically doing drawings.
Yeah, there's we'll get into, I've got a couple of slides of that. We'll get into that with a little bit more detail. Did have one chat over there that you might find interesting. Matt Romanowski, who is helps us co-host here quite a bit. He's involved deeply in the Trans Am series. It goes to all of the events, and the Weaver car Chris designed is very nice. It's beautiful in its simplicity and function, very well thought out. So when I saw that, Chris, I wanted to make sure you caught that chat.
Yeah, awesome.
Very nicely done. Nice compliment.
Yeah, it's been winning too, so I'm pretty happy.
All the rest of it at the end of the day doesn't much matter, right? As long as it wins. One of the interesting things about the car, and we'll kind of just jump into, of course, we're a little bit more focused on the data logger side here, but we're going to veer off and look at some other things. But wanted to chat a little bit about the data logger. We talked about the EECM or whatever the electronic the module for the ECU kind of style of tool, but you needed data. And I captured some of the text from the book here. I just retyped it in. It was kind of interesting. I'm going to go through a little bit of this, and then you can chat about the data logger a little bit. We got some slides and what it looks like, but there was soon the statement here in this paragraph or two almost blows my mind. But there soon was a need to collect data on the engine. Dawn, along with electronics team, developed data logging hardware and software that could be installed on the car to capture engine and chassis data. That little piece right there, Dawn just decided that we needed a data logger, so they went about and built one. That is such a one sentence statement, but an overwhelming task, right? Interesting stuff. What do you remember about the data logger itself?
I'll tell you that in a sec, but I'll tell you that part of the problem we had was reliability. So they wanted to know when the engine was running exactly what was happening. So that's where they started figuring out we need to get data on this, so we know on the dyno what's happening, but we don't know in the car what's happening. So we need to have a system to do that. So they created two types of logging systems. One was a big, huge thing that they used at tests. It was called the Mobylogger, and that was in reference to Moby Dick because the data logger was so big. It was 26 pounds, and it was 15 3/4 inches by 13.5 by 4.5 inches in size, and it was a sealed O-ringed enclosure. And they would strap that in the car and go do their testing, and they were able to get quite a bit of data from all that. So they decided they needed to know during the races what was going on. So they decided to build a micro logger, they called it, and that's this box here.
There you go.
That's basically the micro logger, which is a fairly small little unit, and it was had only like 256 kilobytes of memory. And
while you're doing that, let me bring up this one here just so you can read it as well. But there, that's what you were just holding. Yep.
They had a parallel port or to download it, and you had to get like I think it was a Macintosh computer. Yeah, an Apple Macintosh computer to download it and look at the data. And it was, pretty simplistic, but it at least told them if the engine was running properly or not, and they could make adjustments because there was no, like now you have the loop lambda controls and all that. We didn't have lambda, none of that stuff. So they needed to know at the time how good the engine was running so they could make adjustments for the next session if they needed to. So yeah, it was pretty incredible piece of kit they came up with.
Very impressive for something that obviously they were skilled professionals in the electronic world, but look at the numbers there. The static RAM chips for a total of 256K bytes of data memory. That's a far cry from the 4 gigabytes that we have nowadays on our typical AIM products, right? And a sampling rate of 6.25 hertz. Think about that, right? Mm-hmm. So it's interesting you mentioned that they had gone and did their testing or had been racing, and there was probably some failures, and their engineering mindset, they need to fix them, right? You've talked about that.
Reliability. That's we had the power, and so we just needed to get the reliability sorted, and
exactly, and
making that happen.
And one of the things that we've talked here a lot about is the data analysis triangle, right? There's driver performance is one piece we look for, vehicle performance, and that third one that isn't used as much. It turns out the Electramotive built this entire thing for the most part, was that third piece, which is vehicle reliability, vehicle health. So
Right.
kind of cool that that's what they needed.
Mainly the engine functions back then, because we didn't have shock transducers or ride height sensors or none of that stuff. It was mainly all just to make sure the engine was running properly, because these things were putting out huge amounts of horsepower, and so they needed to make sure they were running properly, especially with a turbo engine. Previous to this, they were using MS or distributors to do the ignition timing and mechanical fuel injection, and the boost was controlled by a valve with a spring-loaded mechanical valve. So Don Devendorf, one of the key members of electromotive engineering and electromotive, he was a rocket scientist for Hughes Aircraft, so he had done a lot of signal processing patents. I think over 30 signal processing patents for used back in the day to what we're using now for these communications to satellites for our phones and everything. So he was the leading edge of all that stuff, and he knew that he went and watched one of these GTX races. It was back then, GTX and GTP back in 1983, I believe it was. He was watching them run those cars, and the Porsches were blowing turbos all the time, and they were $15,000 turbos. And he would go out and watch the flames coming out of them when they would, when they were racing, and he would see different colors. So he's like, they don't have control of these engines. So he said, I got to do an electronic box to properly control this engine so we can get maximum power reliably. And that's what he did. And it's pretty amazing back then what he did. Not even Formula One, he was controlling boost as well. And back then, not even Formula One was controlling boost with their Bosch Motronic systems, where fuel injected, the injection was controlled and the timing was controlled, but they weren't controlling the boost. And not until I think 1987 or something, they started controlling boost. So he was well before his time. And the EECP, it was huge. It was a big old box, not the size they are these days.
Exactly. In the book, there are some pretty good pictures of it, and a few stories and some background. And they were not only creating them for this program, but they had customer EECPs that they were selling to other folks as well. It sounds like so.
Yeah, the first EECP Don design was in 1981, and it was all analog. It used what they used function generators, and what they would do is dyno the engine and get certain points they want the engine to hit. And his first EECP would take these points, and he used these function generators to create straight lines between the points. So it wasn't a curve, it was kind of a jagged line going through, but he said it was far better than all these mechanical systems.
Than nothing, yeah.
Yeah. And what happened was Nissan in Japan found out what he was doing, and they contracted Electromotive Engineering in 1984, I believe it was, to build digital EECPs, that they called the EECP2. And that was funded by Nissan in Japan to supply all the Japanese Group C teams that were running in the Japanese series back then. And so they, because they were able to do that, they were able to make that work with the GTP program as well. So he had a whole group of guys help design that EECP2. And Brett Dusha, John Jackson, and Dave Martin were three of the key guys that were part of that lab team that they did an incredible job with it.
Yeah, and Don was a racer, while being his rocket scientist, right? And there was a tie that from the pictures I've seen, I don't know him or much about the backstory that much, but in the pictures in the book, he's been racing Datsuns at the time, and then the Nissan thing kind of all comes together. So it was almost a match made in heaven, right?
Yeah. At first, he started racing Triumph Spitfires in slalom racing, and he met when he was racing his wife, actually his girlfriend at the time, but they ended up getting married. But she had a TR6, and he started modifying it and making it faster and faster, and they both actually won the male and female championships in solo back then.
Oh.
And then he moved to racing Triumphs, and I met Kaz Kasner, who was the head of Triumph's racing department for the U.S. And so they got a real close relationship. And Kaz knew Don's was a great driver, but he also knew he was a really smart guy.
Yeah.
And so Don actually, when Triumph kind of went away, he started racing Datsuns and started with the Datsun B210, and that's where his electronics started getting into it, where they were building a Datsun B210 and they developed this crank-fired ignition, they called it, because what was happening is they were revving this 4-cylinder B210 engine up to 9,200 RPM. And it was when they would get that high, the torsional vibrations and everything would throw the timing off, and they would blow the motor up. So they were like, oh, we got to get control of this timing. So they built a little crank trigger and built a little unit into the MSD box where the crank trigger sent a signal to the MSD and processed it. And so they actually were going off the actual crank rotation rather than where the distributor was at the time.
Right.
And that solved their engine blow up problems.
Interesting.
And they started selling that unit to people, and people were still having problems over revving the engine in corners. And so he developed a rev limiter, and just to protect the customers from not blowing up the engines they were selling them in these electronic boxes. So that was sort of the beginnings of the whole electronic engine control units he was building back then.
Yeah, the electromotive stuff is when I was racing off-road with Volkswagen Rabbits and Toyotas, we used electromotive crank triggered ignition, and my dad has a drag race car today that has an electromotive crank trigger.
And Don, also, I'll say this, Don was a great driver. He won multiple SCCA national championships, and then moved into the B210 and the IMSA series and won the RS Radial Series championship in 77 or 70, I think 1977. Then graduated to 280Zs in GTU and won the championship a second year into that. Then in 1981, he decided to go into GTO, and they ended up winning the championship with him driving all these years and doing his engineering tricks to everything.
He was a busy guy.
Yeah, he ended up winning multiple championships and started out driving the GTP car. But he ended up developing Epstein's bar, which is you get it when you work too much. He was working night and day. He would go to Hughes Aircraft and work he'd come to Electramotive in the morning before he'd go to Hughes and get there and work in the morning, then get Hughes Aircraft from 8 to 5 or 6, then come to the shop again in the afternoon and work till 10 or 11 at night. So he ended up getting this syndrome, and Kaz convinced him that he needed to take time off, and that's when they hired Jeff Brabham, and the rest is history from there.
And then they were off and running, right? So here's a few more pictures of the internals of the Micrologger. I want to jump back though to that first picture, which these pictures are in the book, and this is a test that 1985 at Riverside, when with the data, probably the Mobylogger, I suppose. But and it's interesting, if you look in the upper left corner of the right picture or the left picture, you see a big roll around cart, and there's papers that are flying. Anybody's been to Riverside back in the day, it was always windy there, right? But there's the output. We're not having some nice laptops and a workstation and we're reading stuff on the screen like we do now. It was printing out the information. Kind of an interesting way of doing it, right? And what kind of stuff was on those papers? What were they looking at when they would get the printout from the logger?
It's mainly the engine information. So boost pressure, fuel pressure, engine RPM, throttle position, those sort of things, just to make sure, like I said before, the engine's running properly and reliably. That was their main focus with all this electronics, was just making sure the engine was running at peak performance and the best reliability they could get. And Ashley Page was a crew chief back then, and he remembers laughing at them with the wind blowing and these sheets getting printed out, and they're trying to control these sheets blowing in the wind and reading them and stuff. So it's pretty interesting time for all those mechanics to see all that going on.
It's kind of funny, but now that I've got a full screen on my computer here, I was assuming it was numbers, but when from looking at it, it looks like it's a strip chart, just like we would have our measures graph in the AIM software, but it's just printing out sideways. It's like the beginning of the session and the end, and there are squiggly lines on the paper, it looks like, and it's probably at every 10th of a second or something, and they can see exactly what the boost and the RPM and stuff was. I didn't realize it was graphs like that, so that's kind of interesting.
Yeah, yeah. I mean, I've got other in my notes that I kept from all those days from MPTI after Electramotive or Nissan bought out Electramotive and formed MPTI, Nissan Performance Technology. I have notes with some of those graphs in my notes, but I didn't have any pictures of those graphs. So, but it's similar stuff,
Yeah, interesting. All on paper, all in the wind.
Yeah.
Right? So interesting stuff. The a couple things that were in the book that I thought might be interesting to chat with, and Matt Romanowski just put a question in the question and answer. Don't answer this one yet because I think we're going to get there in the next little story we're going to talk about. But Ashley Page of Pro System Brakes, and I believe that's a yes, judging from me reading the book. And I think and I'm going to ask a question about some braking stuff here in a minute of Chris, and he can fill maybe a little bit even more on that. Chris, some of the stuff that you did when you got there, when I first opened the book and I was going through it, and I was thinking an engineer, and you'd be working on the aero side and the all of these different things, but you guys, it was a team that was doing it all, right? One of those things that you ended up working on designing was the engine. Give us a little bit of a story about what we're looking at here. It's some of the pictures that are in the book.
Yeah, I was basically the sort of the draftsman, you could call it, on that engine, because what had happened was they ran an iron block, the stock block from the 300ZX at the time, but it was what the first engines were, and we knew, or Nissan in Japan wanted us to build a aluminum block to save weight and make a stronger block, because there was problems with the iron block. We would have failures every now and then. So Nissan in Japan contracted Electramotive Engineering to design and build the aluminum blocks, and that was the job that when Wes said he had a job for me, that's what he had in mind, was come and draw this block, help us draw this block. Huh. So the first day I actually got there with Wes, he took me into the office and he said to me, normally I'd show you around the shop, but we have this important project we need you to do right now. So we went straight up to the design office, and I met this guy named Joe Anahori. So Joe had done a lot of drag racing aluminum blocks, Keith Black blocks, different sprint car blocks. I think he did the Rodak 360 block for sprint car racing. And so he was hired by us to help us create this aluminum block. It was a wet sleeve block, and that's what he was familiar with, which means there was aluminum block, but there was a cast iron sleeve that pressed into the block, and the cooling water would actually contact the sleeve. So you were directly cooling the sleeve. You didn't have aluminum between the sleeve and water. So, but anyway, it was a great experience for me, because I learned so much about how the internals of an engine work, because not only was I was drawing it at Joe's direction, but I was also doing analysis on how the water flow was going through the block, and how the oil flow was going through, and so it just taught me a ton about what actually happens inside an engine as far as the cooling and the lubrication. So and all that at that time, there was no CAD system. We had no CAD system. We had these drawing boards. So all that block was drawn by hand on E-size, full scale E-size sheets, which are 34 by 44 inches, and all the views, front, back, side, left side, right side, top, bottom, and then even section cuts through everything. So it was quite a project, and we had this huge board along the back of the wall where you could put several views up, so I could have a front view and a side view next to each other, so I could take the roller on the drawing board and create the side view based on features I had on the front view. So it was kind of tricky to do, but it was fun, and it turned out to work pretty well. And so I actually ended up following this block through the whole process. When we went to the pattern makers, I would visit. Me and Wes would both go to the pattern makers at first and answer any questions they had and stuff. And after a while, Wes would just let me go, and he wouldn't even come with me, and I would just check and make sure they were all good. And then we went the foundry process, or the casting process too. I was involved with, and inspecting them and X-rays and learning how to look at X-rays and making sure the porosity of the block was good. We had to reject some blocks in the beginning because the porosity was too great in areas that were critical. So that was all really interesting. And we actually ended up putting chills near the main case, or near the main bearing bores, main bearing webs, to make sure that area was dense with the aluminum when they poured the casting. And so yeah, went through all that. And then John Rodak, a company called Graphics, I can't remember the name of the company, but he machined all the blocks for us. So okay. I was going there also and making sure he had, answering any of his questions about what we needed to do and stuff. And so it was just super experience. And then when we first ran the block, we had a problem with water in the oil, and it turned out to be an O-ring problem with the water pump, and where the oil, because anyway, that was an easy fix. And so once we fixed that, we sent an engine over to Japan, and they tested it in one of their cars, and they went about 500 miles and ended up cracking the main cap. The bottom main cap was cracked. And so we ended up going through a whole redesign process on the main cap, and I talk about this all in the book. And we ended up doing strain gauges on the block, and I created this whole system to test it with hydraulic pressure going into each cylinder. We used a mean effective pressure that of an engine cycle they had from the 280ZX engine. So I used that mean effective pressure, and where all the pistons were in each part of the cycle, and I would pressurize the cylinders with the appropriate pressures, and then we would hit the button and record the strain gauges, and then go to it's in 15-degree increments. And so I did the complete 2 engine cycle to see what all the stresses were and everything, and we found that these main caps weren't good enough. And so Don Devendorf came up with the idea of, instead of just a main cap that came straight down, it actually came down and then flared out at the bottom to miss the counterweights. And that flare out at the bottom is where you want all the strength in a mechanical situation anyway, to improve the strength of the part. So that proved to be really the key to making the engine work. And it ended up in the end being a stronger, more reliable block than the iron block.
In the process of when you walked in there that first day with a clean sheet of Mylar, I suppose, and this thing going out and running its first race, what kind of time frame was that?
It took a year or two to do it. And the good thing is we had the stock drawings from Japan. So
for the iron block that you were trying to just replace, right?
Yeah, right. Okay. But it was all in Japanese. So we had no idea what it was saying, but the dimensions were all metric. So that was the main thing. We knew all the dimensions, but trying to read the details of what they were saying was impossible.
The language barrier, a little bit of the metric English stuff, but the language barrier, the bigger problem, right?
Yeah.
And at the end, what kind of horsepower was this thing putting out for you under full song, full turbo boost, the rest of it?
Well, it could, the aluminum block, we had the ability to go to 3.2 liters. With the iron block, it could only go to 3 liters. Well, with 3.2 liters, it was putting out about 1,200 horsepower. Wow. So, and that was with the stock cylinder heads. So it still had the push rods. So that was the limiting factor, was the RPM. We could only burn, I think they ended up getting about 9,200 RPM. Wow. Because of the push rods, and did a lot of stuff with the springs and the whole valve train to try to maximize how much RPM they could get. But it was just, throw a ton of boost in there and until it broke, and then back that off a little bit. And that's kind of where they ran it.
and re-engineer it and then throw a little bit more yet, huh?
Yeah,
Right. So
exactly. Get
yeah.
more the better.
Interesting. This is the kind of information that is all through the book, fellas. It's amazing. The strain gauges he talked about. I think there's some pictures of the hand calculations of that, and there's some pictures of hand calculations of aero from one of the Japanese engineers, if I remember right.
Yoshi.
Yeah, that's the kind of stuff that the book is just full of. If you're interested in that kind of stuff, it's a gold mine of just information of what was going on when this program was put together. Yeah, here's a little bit of your hand drawing that
Yeah.
some of the stuff you were working on around the same time that you were working on the engine. You probably were working on other things as well.
Yeah, this was a front upright, and it was magnesium. You know, these days you can't put magnesium in a race car, but we had magnesium all over this race car because carbon fiber wasn't what it is today. You know, carbon was mainly just coming around and being used as bodywork. There was no brackets made or anything out of carbon. It was all out of aluminum or magnesium or steel, depending on what you wanted to do. So this was a magnesium upright that was similar to what we were running from Lola, who originally built the car. But the funny thing about that was the Lola uprights were built out of this RZ5 magnesium, which was partially radioactive. So it was illegal in the U.S. at the time to pour this material. You could still do it in the UK, but getting it over to the US was impossible. You couldn't ship it over because of the radioactive part of it. So we actually had to research and come up with a different type of magnesium to replace it. And I think we came up with a QH type of magnesium that was close, still not as strong as that RZ5, but it was close enough, and we beefed up to this a little bit to take care of it. So yeah.
And then you transitioned. And then transitioning, you while you're there working in the program, CAD becomes available for you. You talked about it in the book. And not only did you start designing and working in CAD, but you had to convert some of those other hand drawings back in so you could continue to move forward. Give us a little idea of what we're looking at here.
Yeah, this was my first drawing I ever did on CAD.
Ah.
And what we had was Anvil 1000 MD, which was a 2D software. So there was no 3D or model. You know, there was no solid models back then. It was all 2D, and it made designing stuff way better because not only the accuracy was better than your hand drawing, but you could, if you needed to make a change, you could just copy it and start over. Right, with a hand drawing, that was the only drawing, and you know there was a lot of changes to stuff, and sometimes I would have holes in the paper where I was erasing stuff and fixing it. And a lot of times we had to do sepias, which are like a blueprint, but a blueprint you can modify. And so that's how we had to deal with that. But once we got into this CAD system, it made things a lot easier. And it was really just a 2D drawing platform. So in this drawing here, you can see I've created cross sections through the beam, because on the outside there was a spring, the rear shock spring force was loaded there. Yeah. And so my job was to draw it and then make sure it was going to work. So I took sections,
calculations and such.
Yeah. And calculate the section modulus of each part. And through a moment diagram, I was able to figure out the stresses of where it was through each part of the beam. And yeah, all those calculations were there was no simulation or any of that, you know, back then. It was all I would break out my books from college and use them, my mechanical engineering books, to help me figure out how to do all this stuff, you know, remember how to do it all, you know. So
you'd learn the X's and Y's, but making it in a real world in a race car like this is, you got to apply it, right? It's always slightly different, obviously.
Right. Yeah.
Interesting. You not only did you build the engine, you talked about that. There's lots of discussion about that in the book, but you also worked on the transmission. You were telling me that you designed it, you helped draw it, helped design it, and then later on you get some of the pieces, and you're there assembling it. I mean, it's really quite a remarkable story.
Yeah, that was the GTO program. We were
that's right.
Cunningham was running the GTO cars, and Trevor Harris designed the cars, and we were in electromotive engineering was given the task of doing the gearbox, because the rules back then were gearbox had to be in the same location as the stock gearbox was. So it couldn't be a transaxle. It had to be a front
Transmission.
transmission. Yeah. So my boss, Wes Moss, he started the layout. He did basically the design, the layout of the thing. And so I took his layout and created all the detailed drawings and worked on the oiling system and everything. So Wes is pretty much the designer. I kind of did the detail stuff with him, but it was another project like that engine project. I took it from beginning to end. I was involved with I drew the castings for the bell housing section of it. We used VG30 Hewlin VG30. I'm sorry, Hewlin the Hewlin VG internals we used that were in the GTP car. We used that for the internals on this GTO car. So we basically built the cases to made up with all that. And so I was involved with the casting process and the machining, and then they had me actually build the first box in the shop while the guys are over here working on the GTP car. I'm here building this this transmission for the GTO car, and it worked pretty good straight out of the box. We actually had a quick change on the back of it also. And the biggest problem, or really one of the only problems we had with it was when I was designing the quick change, the speed of the shafts and the size of the snap ring that went around the shaft were such that the TrueArc's catalog told me that you can't use a single snap ring because the inertial loads would open it up and it would come off. And so they had this other type of snap ring that had this two-piece that interlocked together. And so we decided to go with that, but that ended up being a problem. That would come apart.
Oh.
And so, and we were trying to figure out how we were going to fix that problem. And Trevor Harris came up and said, hey, why don't you just go down to the next size snap ring, the one-piece snap ring that's a little bit smaller. You'll have to spread it a little bit harder to get it on, but it's not going to have the spring that's going to allow it to come off. And that ended up actually fixing the problem, going one size down on the one-piece snap ring. So that was
all of this technical engineering, and in the end, somebody that's pretty smart just found a way around it.
Pretty practical. He was a pretty practical guy.
He's the chassis designer later on, right? When you started with some Lola stuff, and then you started to build your own. And Trevor, lots of pictures and lots of information about the chassis in the book, and a lot of the work that Trevor had done. One of the things I found was I wish I had the link. I'll try to find the link and put it into the YouTube description below. I found a video where Trevor was chatting with a couple of guys, and they had one of the, don't know if it's a GTO or the GTP car, but I think it was a GTP car, and pointing out some of the stuff that he did as a chassis designer. Pretty interesting fellow to listen to.
Yeah, he was super smart, and I learned so much from him. Not only from design aspect, but also race engineering. He was basically our race engineer from 1988. Actually, he started, and he was switched on. He never actually got a degree in engineering, but he started out as a physics. He started out taking physics in college, and the college got in the way of his racing, so he quit college to concentrate on racing, and up in the Seattle area actually is where he started.
That's what I remember hearing that about in my neck of the woods up here.
Yeah.
There's before I'm gonna minimize this down so you and I can chat full size, but there's a picture of Don and some of his earlier winning cars that he had ran, and
John Knapp there too. John has since passed away, but he was a key to making this whole program work. So he deserves a lot of credit.
If you download the presentation, I think the link has already been in the chat, and it'll be in the YouTube description down below. I've got some slides here that Chris has used at some other presentations. And we're not going to go through them all, but I think that I wanted to get a picture of Wes that you've mentioned several times. I wanted to have his picture up there. Those slides, you can go look at those. A lot of those are the exact same pictures that are in the book as well. So. Okay, let me stop the share just for a second so we can chat. I want to do a couple of other topics that I thought were kind of fun to chat about. We've got about another 5 or 7 minutes. There was a couple of things that I read in the book that I thought were interesting stories that maybe you can chat a little bit about. There was a story you talked about where there was some on the GTP car, there was some tire problems, and these cars, we had PJ Jones from the Gurney Eagle with us a while back, and he chatted about how much downforce these cars made, and of course the Nissan GTP was right there, if not greater numbers. Talked about, you went to Portland, a local track here to me, and put some spring load data. You were blowing tires and trying to figure it out, and give it a little bit of the behind the scenes story on what happened there, and what the Bridgestone tire engineers found, and what happened.
Yeah, I mean, one of our main problems in the beginning was with the tires, because nobody really knew back then. They didn't have, these aerodynamicists were creating these huge amounts of downforce, and so the tires were taking a huge amount of load. And we had sponsorship with Bridgestone in the beginning, and they kept telling Bridgestone, we kept blowing tires and damaging cars and hurting drivers and stuff, and I talk about all that in the book too, but we wanted to let Bridgestone know what kind of loads they were dealing with. So that this test we set up, I think 2 weeks before the Phoenix race, the Bridgestone engineers came there, and Yoshi Suzuka had been telling them what kind of downforce we've been making, and they didn't really believe him. And so they came and put these load cells on the car, and they did a few laps, and they came in and said, sorry, we can't really let you run our tires anymore. Our tires aren't going to work. And so, we kept running them the rest of the year, but I think they might have increased pressure or something to help them out. But at the end of the year, Don told him, he said, you guys, you got to fix these problems, because you're creating more damage than we're getting out of the sponsorship. I think he said they were getting about $400,000 a year in sponsorship, and they're creating way more damage. And Bridgestone said, no, we can't afford paying for the damage. So Don and Kaz Kazler made the decision, okay, fine, we're going to go with Goodyear tires, and that was one of the key moves. And that was the beginning of 1988, and that's when the car started to come around, and the Goodyear tires were actually a little better than the Bridgestone tires, which helped, and they were more reliable. So it was one of the reasons the whole program got turned around.
Interesting. The just another way of putting data, in the car. In this particular case, from one of the manufacturers of product. But kind of a funny story.
One other thing to that is, back then there were no spec tires, so tire companies, they were trying to make the fastest tire they could. So it wasn't uncommon for people to blow tires of all different types. I mean, there was, Goodyear, Dunlop, Yokohama, BF Goodrich, all these tire companies were involved, and it was a tire war. So you don't see that today, and almost maybe off-road still has different tires, but as far as road racing goes, everything's spec now. So you never hardly see tire failures. You will on occasion, but usually they'll fix it, and so everybody's got the same thing. But back then it was, make the tire as fast as you can and as reliable as you can, but sometimes it didn't work out.
Yeah, not only the cars that you were building, one-off cars that were just out at the outer edges of the engineering that as we knew it in motorsport, and then things like the tires. They were trying to make them as fast, as light, as thin as they possibly could, but yet still to do it, to not slow you down. But they also had to do their development work as well, and there's a peak there, and sometimes you sneak over that edge, right?
Right. Even Goodyear had to relook at their tires once they started getting the data from us. So
you guys were that class where you had the Gurney Eagles, you had the Nissan, obviously you had Corvette, you had the Jaguar, you had there was a lot of players and a lot of effort and a lot of money coming in there. You guys were pushing very, very hard.
a lot of manufacturer involvement, which made it such a cool a cool time in racing.
Gives you the ability to have some funding to do those kind of things, but it's also just a ton of work, right? And hard work. So talking about the Jaguars, there was one other story. We have time for probably one more, but then we'll try to close up with a couple of questions. There was a story in there that I found interesting, and it was a small little story, but you were also developing brakes and the brake package, right, to handle this additional speed and additional downforce and all these different things. So you were working on different brake packages and rotors and some other stuff. So you went and did a test, and I tell a little story about that brake rotor story. There was a little bit about the smooth versus the grooved rotors. It's kind of an interesting thing.
Right. Yeah. No, we realized early that or Don Devendorf actually did some calculations and worked out that we weren't using the brakes as good as we could at top speed. So we concentrated. We had so much downforce that the Brabham could just stand on the pedal as hard as he could. He could never lock the tires up at speed. So it became, all right, we got to do something. We need to get more pressure.
Need more
bite. And so Performance Friction came along and did a test with us, and they proved to be a better pad than I think it was a Ray Bestis 19M pad that the Porsches were using, is what we were using too at the time. And then when Performance Friction came along, their pad was much better. And so they said, hey, I think we can get more gain if you ran a smooth disc rather than a disc with the the veins or the cutouts in it. And so they did a test because our team didn't agree with Performance Friction. We thought that it needed the grooves in the face of the disc to keep the pad fresh, this pad surface fresh. So they went and did a test, and they had solid discs with no grooves in the surface, and other discs with different types of grooves, more or less grooves. And they did a test with Jeff Brabham, and they went through the whole process with it. And Jeff told him what he liked better, and it turned out to be the grooved surface discs. But in order to verify it, they actually didn't tell Jeff what they were putting on the car at the end of the day, and he could pick out exactly which disc that was on the car. And so from then on, they started using these grooved face discs, and it turned out the Performance Friction needed that groove to wipe the pad to keep a fresh surface for the next application. So
and motorsports being like it is, it's a small world, right? And pretty soon other teams were starting to hear about it, and there was a little story that follows up, but just one of these technical stories that are just so cool in the book, all through the book, that the Jaguar team found out the Performance Friction pad, and they started to work with it, right? Tell a little story about what happened there.
Yeah, well, the Performance Friction pad worked really good at high temperatures. Like it could actually go to a higher temperature than the Ray Bestis pad could. And so we'd been running them for a few races that year, for most of the races actually. And then the Performance Friction offered them to the Jaguar team, the Tom Walkinshaw Jaguar team. And Ashley talks about a story when they first ran it where Performance Friction said you want to run them hot. So before the race, Ashley said normally the Jaguars would be in pit lane getting their tires ready, fueling up. And he said he saw them taping off the brake ducts. And so he walked over to one of the mechanics and says, hey, what are you guys doing there? And he says, well, we got these new pads from Performance Friction, and they're supposed to run hot. And so we're going to see what we can do with these things. And so they had the brake ducts taped off, and I don't know how much they had taped up, but I'm sure they had some airflow to them, but not much. And Ashley kind of walked away and thought, we'll see how that works out. We had tuned our brake ducts to work with these brake pads. And so the race starts, and he said it, and Ashley remembers about 10 laps into the race, here comes a Jaguar down pit lane with the brakes on fire. And he said they had to replace the uprights, the brakes, everything, the whole corners in the fronts to to get the thing back out there again.
It's you guys have done the testing and figured out, yeah, they do feel pretty well at that high temperature, but they get out of hand, and it gets too much, right? And you also shared, and I think I even read it in the book, that Jaguar came in with a bit of an attitude. They were going to come in and pretty much just take over. So it's kind of a little bit of a funny story that they're struggling on a little thing like that. So
Yeah.
kind of interesting.
One of the comments that Tom Walkinshaw said, I think I've got it in the book. He said that we'll be pleasantly surprised if we can win more than 50% of the races.
Oh, oh man, yeah, ouch.
So we ended
They were
up winning, I think, 8 in a row and 9 out of the 12 races. That was in 1988.
I trust that he was not pleasantly surprised.
Yeah.
So we're kind of running out of a little bit of time, Chris. We just touched on as I thumb through the book, and I see that just virtually on every page there's little stories like this that are just so deep inside. The process of putting this together, how long did it take to put together the book and bring all of these? You reached out to tons of people. I've chatted with a couple of people that you knew that we're working on the cars in the vintage world now that you were in touch with. And how long did it take you to put this whole thing together?
It took a couple of years. And the reason I wrote it was because, for one thing, I knew it was a great story even when I worked there, because it was such an awesome place to work, and the technology we were using and everything was great. And I'd seen a lot of stuff on the internet that wasn't true about what had happened, and I wanted to set the record straight. So what I would do is I would write a chapter, and then I would send it to all the people that worked in that area and say, hey, have a look at this and just let me know if I got it right. If I got something wrong, tell me, because I want to make sure everything is true. And I wanted everybody that had worked there to be proud of what I did. And the response I got from everybody was huge. I mean, I would get emails from everybody in all the different areas, just these huge emails that would tell me about the different aspects of what they worked on. And even Ashley, I got one email from Ashley, and at the end it was about a 5-page email. And at the end of it said, well, it's 2:00 in the morning, so I got to stop and go to bed. I'll give you more information later. So, and it was just great reconnecting with all these guys, because, when you're on a race team and you're working so close together, you create a bond. And so it was great just to talk to everybody and get everybody back together again.
Absolutely. So. And the couple of guys that I spoke to said you were the perfect person to write this book, because you're well liked in the team, hard worker. You were around a lot of the different pieces, and everybody was very willing to chat with you. So that's a testament to your position on the team as well.
Yeah, I appreciate that. I mean, it was great for me because I was involved in everything. I mean, I was engine, the transmission, some of the body work, the chassis with Trevor. I helped him a little bit on some of that stuff. So I just learned so much back then, and I'm so grateful for all those people that taught me all that stuff. And Absolutely. Wes Moss, who gave me the opportunity, is just awesome.
Amazing when you do things that work as hard as you did. It's like you say, you create a bond that's a lifelong thing. So let's jump back into the presentation to kind of close this down a little bit. The book is available at many different spots. I suggest, I strongly suggest that if you like this kind of thing, this might be something that you might want to grab. It's a book that you're certainly not going to read it front to back in a day, but I just love sitting down when I do have a few free minutes and thumbing through it and seeing some of the different stuff. So I think you'll enjoy it as well. Chris has an auto racing book site. You can grab it there. Of course, it's available like everything else on Amazon. And for those of you in Europe, there's down at the bottom, there is a European distribution spot for a website there that I've linked. All of these are available to you. If you're watching this video, download the PowerPoint of this presentation, and all of these are hyperlinked, so you can find these pretty darn easy. So,
and I just want to say I'm offering free shipping from my website through the end of the year for the holidays. So if there's a gift, if you've got a racing fan that likes this era of racing, it'd be a nice gift to give them. I
heard that there might even be a chance that you might sign a few of them if somebody asks real nicely, right?
There's a place when you go to order in view cart that says add a note to the author, So if you click on that and just ask me to, I can personalize it for you or whatever. So just leave me a note there and I'll sign it for you.
Perfect, perfect. I think it would be great. I've very much enjoyed the book. So the just we're right at the time limit here, but I thought we would chat about. There was one here that we do have too many to probably ask, but Kyle asked a question that I do not know the answer, and you may or may not. But were the failures at the '92 Road Atlanta event, I suppose, ever nailed down? I understand that almost ended the Nissan program in IMSA. Does that ring a bell to you?
Yeah, that was a big moment. We were making a lot of downforce with that '90 GTP car, and going through the dip at Road Atlanta. That was before they put the left right before the bridge. You went through that dip.
Amazing speed.
High speed, and so the tires. We blew 2 tires on those 2 cars, and it just about knocked us out because we didn't have a huge budget, and those cars were destroyed. So we ended up it was a big hit to us for sure.
Right.
And Goodyear, I mean, it was a surprise. We didn't think that was going to happen. We thought that Goodyear had it sorted out, and just I think it was this situation with that track and the loads that we were making. It just overloaded those tires, and we weren't the only ones that had those problems. Dunlop was blowing tires on occasion, and so it was like I say, it was a tire war. So everybody was trying to get the most out of those tires.
And the amount of downforce that those cars were generating at that time was virtually unheard of, right? So there was new forces on these tires that they didn't expect as well.
Right. We were actually working on a '93 GTP car, and the aerodynamicist at the time was Andy Borm, was working on it, and he could create 10,000 pounds at 200 miles an hour with that car. And we never built the car because they closed down before we could build it. But it just kept escalating because there were no rules,
Yeah.
No downforce, and so
there was I'm going to jump back a couple of slides right there. You included, it's in the book. There's a pretty long story about it. I just wanted to share these pictures of John Morton crashing the car, going flipping up and over at Lime Rock, and in 1988. Lucky to get out of that alive. You can see the car was just torn apart, and he was just kind of hanging out of it. I understand from what I think is in the book that his helmet even came off at some point.
Yeah,
just crazy.
You can see actually on that far right view his helmet. Yeah, right there, his helmet's on the dash, and his head's actually back there where you can see Brabham attending to him.
Okay, that's Jeff Brabham right here.
Yeah. Mm-hmm.
Okay, and that's his helmet off of his head. Amazing. But and then you told, I know we're running a little late, but then you told a story that you had not been at the event, and you're back at the shop. You hear how things have gone, and then he showed up or something, right?
Yeah, we were all devastated by this crash, and
obviously,
this Gene Rosentowski, one that was there to take all these photos. I have the whole sequence in the book. There's more than these pictures, but me and Bruce were back at the shop, and I think they had another race. This was, Lime Rock. This was at Lime Rock, and this is why there's now a chicane at that hill.
Exactly.
There was several other cars that had flew before we did, but once this happened, they changed the track. But John comes into the shop a couple weeks after this accident, and comes to see me and Bruce at the shop, and he has these pictures, and he's showing us these pictures. We just knew he had a crash. We didn't know how bad it was. And so me and Bruce are sitting there looking at these pictures, and John's standing right next to us, and we're going, John, how the heck are you here right now?
Yeah. It tore him up a bit. It tore him up a bit. You have some pictures, I think, in the book that show, there's a pretty good scar on his face at the time. And
he wore an open face helmet with a mic. And when the accident happened, his helmet got ripped off, and his mic ripped his lip open. So he had a big, he's bleeding badly out of his cheek. And it looked a lot worse than it did. It was, because it just was more plastic surgery that needed to happen. And he was lucky because it happened on a Friday, and the plastic surgeon near the hospital was going on vacation, and they were on Saturday. So they wouldn't have been there on Saturday if it happened Saturday, but it happened Friday. So he was able to get his face fixed.
Wow.
That afternoon. So
yeah, crazy.
And we learned a lot from that crash as well. So that's all in the book too. So.
It's amazing stories, fellas. If you are interested in it, there's some spots to get it. I see a note in the chat from Brent Ducia. I mentioned his name earlier in that one quote, and I did not know that he was here. I don't know if you have the chat open or not, Chris, but he's in here chatting to you.
Brent was one of the key guys doing the electronics.
Yeah. Yeah, in fact, I put his name in the electronic section there. I just noticed the name. Perfect. We are just a touch long, but there's where you can get it. I strongly suggest you get it. It's just I just enjoy the background, the information, the engineering side. A very, very cool story, and maybe we'll bring Chris back at another time to talk about a few more of the different stories in there. But appreciate you coming.
Yeah, I want to thank you, Roger, for inviting me, and I appreciate everybody that joined in to watch. I hope you enjoyed it.
Brent says in the chat over there that he believes John wore a full face helmet after that accident. Yeah. My guess is that would probably been a smart idea. Mm-hmm. This live webinar, of course, is being recorded, and we're within an hour or so, just as fast as I can work through it, I put it all together and I upload it to YouTube. It'll be there with about 175 other videos that we have done, including these 110 webinars that we have put together. So if those of you that are watching it live, if you want to replay a little bit and see this, go check it out there. If you're watching it on YouTube, there's a whole bunch more that you can go visit and take a look at. We very proud of what we've done, and we got a lot more scheduled to come and continue forward with this project. So we are a customer support company that happens to sell racing electronics, and we are traveling like crazy out there, all of us AIM staff and visiting places. I myself, we chat a little bit about where I go, but I'll be at Portland this coming weekend for the IndyCar event and hanging out there. And then the weekend after that, I will be at the NASA Nationals at Daytona for those that 4 or 5 day event. So if any of you guys are watching and you're at those two events, come up and say hi. I'd love to chat with you. Matt, Matt Romanowski is going to be a co-host coming up. Matt, we had some shots there. Lime Rock. Matt always we always show Matt's data from Lime Rock as some of our explanation data that we use in some of our events. So that Nissan was probably going about as fast as Matt's 914. I seen a couple people joke with Matt over in the chat box. So, oops. What are we doing next week? We're gonna jump back in and do some technical things. And one of the karting is one that we try to fit one in about one a month or so, one every 6 weeks. And we've got a co-host coming back and joining us. Eric Gunderson from Point Karting will be here, and we've since he's been on, we've chatted with him about 3 or 4 different ways of looking at data. This one is going to be kart data analysis, 3 fast tricks. We're going to bring up some data. We're going to look at 3 tricks that he does, some processes that he follows, and do it actually with data and walk through the process and see exactly how he does it and see the results of the analysis. And we talk about those 3 things we always talk about: driver performance, vehicle performance, or vehicle health, and different ways that we can do that with our Micron products in karting. So come join us a week from today with Eric Gunderson from Point Karting. We'll looking forward to having Eric come back and join us again. It'll be a good time. Some contact information. We had it on that last page a little bit, but here's some information about our co-host, our guest today, Chris. He's got the Chris Willis autoracing-books.com site and the Willis engineering site, something we didn't talk about, but a website where he is still active and doing engineering work in motorsports. So you might want to visit that site and see if there's anything you can do there. Something we didn't talk about, but just because we were so wanted to focus on the Nissan GTP car, but Chris was a big part of the some off-road world, and some of those there's a couple chapters in there about the Mickey Thompson Nissan off-road stadium truck team that he was a part of and designed a lot of. And then the picture I'm showing here is of the Ivan Stewart series trucks called Pro Trucks that Chris was a big part of in engineering and designing those off-road race trucks. So Chris has got a wide variety of engineering that he's done in motorsports for a good, long, healthy and a career that he has every right to be proud of. So Chris, anything else you'd like to kind of close us up with as we kind of close this one down?
No, I just appreciate Roger you reaching out to me and having me here, and I'll say it. My go-kart has an AIM system on it, so I appreciate that also.
As it was funny, the very first time we chatted, I started to explain a little bit about what AIM was, and he actually stopped me and said, "I'm familiar with your stuff. My go-kart has a Micron on it." So I knew we were in good shape within the first 10 minutes, 10 seconds of our conversation. So I appreciate you coming, Chris. It's been a great time. I've learned a lot, and I hope everybody here enjoyed it, and I know they did. Thanks for coming again. I appreciate it. Hopefully, maybe we'll have you come back and join us again. So everybody, buy the book. It is well worth it. We gave you some links to go out and do it. John's website. He's going to provide that free shipping. So that's a heck of a deal. It is a large coffee table style book. So shipping is not. It costs a lot to ship. It costs a lot to make, I'm sure too. It's a hardback, color, glossy book. It's very nice. Thanks everybody for coming. Thanks, John, Chris, for joining us. Appreciate it. And everybody, we'll see you a week from today. Talk to you soon.
Thank you, Roger.
Thank you.
Thanks, everybody.